This conference will now be recorded.
Hello, everyone. This is Liz Klein. I am the GOZAR Product Quality Lead, and welcome to the Satellite Book Club Seminar Series session number 190. Today, we're going to be hearing about using Google Colaboratory to obtain and visualize archived GOES satellite data. Our presenter is TJ Turnage, Science and Operations Officer from the Weather Forecast Office in Grand Rapids, Michigan. Our facilitator is Jonathan Howell, the Science and Operations Officer from the Weather Forecast Office in Mobile, Alabama. I'd like to remind everybody that this session is being recorded. A question and answer will happen after the presentation, but we encourage you, please, to post your comments along the way in the chat room, and they will be fielded from there. Please mute your microphone and turn off your webcam, and sign in with your full name or specify your name in the chat when asking a question. We are always looking for future presenters. Please contact the Tower S team. There will be a link to the presenter and facilitator form put in the chat. Fill that out if you're interested in doing one of those roles. The training team can help build your training materials. If they are unavailable, you can contact Ross Santil for information or questions regarding that. We also like to thank the OCLO, GOZAR, and JPSS program offices, and our facilitator, John Howell. TJ Turnage has been the Science and Operations Officer, or SOO, at the Weather Forecast Office in Grand Rapids, Michigan, since he arrived from Tallahassee, Florida in 2006. His interests include mesoscale meteorology and data visualization. TJ, welcome to the Satellite Book Club.
Hello, thank you for having me. Hopefully you can hear me okay and see my screen. Awesome, thumbs up. So yes, so what I'll be talking about is something called Google Colab, which may be familiar to some and maybe new to a lot of you. So I think once you see what I have to present, you'll be excited as I am about what some of the possibilities are with it. So what I'll start with, going through the presentation, I've got three parts here. First, a description of what Google Colab is, and then describing how it can be used to obtain, plot satellite data, and actually many other data sets as well. And then we have an actual case study to look at. You saw on the very first slide kind of a sneak preview of the case, and we'll get into that a little bit more as we go. First off, what is Google Colab? The full name is Colaboratory, but for short, it's called Colab. And it's a way to basically share code, share programs through something called notebooks. It works in the Google Cloud infrastructure. And so the nice thing about that is if you've got a Google account and you got an internet connection, you are cooking with gas for being able to run Google Colab notebooks. So even though I will talk about Python, which is a programming coding language, to use these notebooks, you don't need to know how to program in Python. You can really be an end user with a minimal amount of knowledge, just basically making selections for what you're after, and hopefully that'll become more evident as we go through the presentation. I did have include a YouTube link at the bottom left, which does have a really good overview of Colab. So I encourage you to check that out. So one ingredient is Google Colab, but then the other is now that we have data in the cloud, that's really opened up a lot of possibilities. So there is an agreement between NOAA and AWS, Amazon Web Services, and their cloud ecosystem, where you can access pretty much all of the NOAA data sets. So this would include satellite data, radar data, a whole bunch of other things. So I actually encourage you to go to this link here that's on the page, and you'll be pretty amazed at all the data sets that exist. And so if you're running a program in the cloud, and if you've got data in the cloud, that's a beautiful beautiful situation there. Okay, so the other thing that makes Google Colab really nice is that as the name implies, Colaboratory, it is a collaborative type of system. It's just like sharing a Google Doc, right, in Google. So it's very easy to share the code. You can either do it as a link in your Google Drive, like I show here at the bottom left. The other thing, I had sent John a link to this right here, which is an ugly looking link. But the thing that's cool about this is you can use something called GitHub. You click on the link and then you'll see a button that says Open and Colab, so that anybody with a Gmail account could open up the program and run it. This is significant because there may be people on this call who are not in NOAA, but may still have a Gmail account, and this would allow them to access it. So we wouldn't have to be concerned about, sharing a document, for example, with an outside of NOAA source. The scrolling item here, which I realize is maybe a little on the distracting side now that I look at it, this is something put together by Western Region, and this just shows all the examples of how a Colab notebook can be used to access just the wealth of data that's out there. So as it scrolls by, you'll notice things like, first of all, there's the video there that I also linked, the YouTube. You can download radar data, buff kit data, climate data, NBM data, all these kind of things, MRMS data. So I'm happy to talk with people on the side or afterwards just about all of the possibilities that are out there. Most of these links I put up here, I really do encourage you to check out. So moving along. So next, what I want to do is show a particular notebook that relates to this presentation. And so this kind of is an example of the interface, how it works. And so what you're seeing here is it's like having a, say, Google Doc open, right? But this is the actual interface. It uses something called a .ipynb file, which you don't really need to know that. Just realize that when you see that, it's related to the so-called notebook, and it's kind of like an interactive form that's running the code in the background. So at the top of this, you'll see kind of an introduction to what's going on. But then this is where kind of the magic starts right here. This is where you can be interactive. So for example, you can select which satellite you want. You can say, all right, you can choose GOES 16, GOES 17, 18, for example. Then in terms of the start times, if you want to do a plot, say, well, in this case, I'm doing it for the 7th of May, so it's a little while ago, but you can pick your start hour, start minute, when it ends. You can decide, all right, when you create figures for it, do you want to use a particular time zone? Do you want to use UTC or Zulu time? You can define your plot boundaries in lat-long coordinates, so that might require a little bit of experimentation, obviously, to help you figure out what tells the story the best in terms of how zoomed in you are. There's also some other options where, and I'll talk about this in a little bit, but you can plot roads, plot counties, you can make animations. So this is all highly interactive, and again, you don't need to be a Python person to go in and just fill out the form here. So after you've done that, then you can select up to 6 different panels. And what I did here is I included links that explain basically the references of the individual channels or of the RGBs. And this would help obviously inform the decision of what you wanted to include or not include. These RGBs are sort of come out of a cookbook, right? There's sort of ingredients to it. There's somebody named Brian Blaylock, who's done a tremendous amount of work on these recipes, and so I've borrowed very heavily from him on that. But anyway, you choose however many panels you want, and that'll sort of dictate the layout of what you end up plotting. So then you run the code, and eventually you will get output of the individual images. The way you access it is where I've got the red arrow there. You click on that folder. It'll expand out what you see on the left side there, and then you have in the images folder, you'll see that there are individual mosaic images that were created. Also, there's an animated GIF, and also all of the images just zip together into one file. And so similar to how you work in Google Drive, you just do a right click over it and select download. So I realize that's kind of going very quickly. I was sort of on the fence about whether to do a live demonstration instead of these screen captures, and maybe if there's time, I can attempt to do more of a live demonstration, but we'll see how it goes. So anyway, once you download the results, these are the kind of things that you can get. So there's an animated GIF there. There's also the individual images, so you may want to use those for a case study or research, that type of thing. So I guess I should have prefaced this a little bit earlier. I would say probably one of the most challenging things in my career, being like involved with research and training, which of course that involves everybody to some degree as well, is how do you get satellite data after the event's over? It just kind of falls off the map, and it's really hard to go back and grab. So this is a way of doing that. That's kind of the idea here. It's now possible to really enforce the idea of a culture of review. I'm a very big believer in that. And any way we can just quickly look at the data in a very quick turnaround type of fashion while it's still fresh on people's minds, I think it's really, really useful and highly educational. So we've got plenty of ways of doing that with radar data. We have had radar in the cloud, obviously, and we leverage that a lot, playing it back in things like GR2 Analyst, but it's always been rather hard to do with satellite imagery, and I think this poses a way of doing it that's really going to be accessible to more and more people. All right, so here's a particular case study. So kind of fortuitously, we had an event a little over a week ago. It was on May 7th. We had an EF2 tornado that occurred just south of we're located here in Grand Rapids. So we're talking far southwest lower Michigan. So the radar loop up there gives you an idea of how things progressed. And then I did just a simple 2-panel here of how it evolved. So notice here I'm using a RGB, and there are plenty of other RGBs that can be chosen as well. So that's another thing that's been very challenging is, hey, how would this RGB have worked? This gives you a chance to kind of play in the sandbox a little bit with that as well. So one of the things I found so interesting about this case is obviously not only the radar aspects of it and the mesoscale aspects of it, but there were some really interesting billows going on there. So what I'm referring to, it looks like you can see my cursor, it appears. So notice these features right here. It starts out as a very, very stable environment, and you've got this real interesting complex billow looking setup that occurs prior to surface-based convective instability working into the area. You get the much more cellular look, but it's a pretty fascinating evolution. It's also super evident how impressive the shear is, when you compare the low-level flow with, the motion of the anvils. I mean, some pretty healthy looking supercells going on. Even see indications of billows over Lake Michigan here. So that was something I wanted to delve into a little bit more. I was actually working during this event, and I was thinking, wow, those billows before things really got going were quite interesting. I want to dig into it a little bit more, and here we are. We've got the data to look at. So just kind of taking this case study a little bit further, I went ahead and looked at a hodograph. So this is based off IWX's radar, and I thought this was kind of a cool look right here, because I will also say this hodograph was created by leveraging AWS. It just pulled radar data out of the cloud and was able to create it. That is another notebook as well. If you're interested, I can chat with you on the side about that. But notice how you've got a shear vector, right, according to that hodograph, that's pointed towards the northeast. And that absolutely makes sense. There's a concentration of pretty strong low-level shear in the lowest kilometer or so. And notice how it is normal to the orientation of the billows, as you would expect, right? I mean, that's typically an indication that you've got really good shearing going on down low in a weakly stable environment, or I guess stable that was transitioning. You can kind of see how it looks a lot more stable here, but then you're starting to get what looks like more convective agitation. So that's kind of a neat way to look at it. And then you can also continue to compare that with other things. So here's the Cape. So you can see how with these hatching here that it looks like the instability, the convective inhibition is starting to peel away a little bit, and we're seeing more and more um, mixed layer boundary instability coming in. And then this is also kind of similar to what we saw in the photograph, how you've got shear vectors, 0 to 1 in this case, kilometer shear vectors pointing to the northeast. And then, of course, here's the surface observations as well. So there's just a lot of really cool ways to tie this stuff together. I think it's going to go a long way towards helping us integrate satellite data sets into mesoscale analysis, because of course it's really easy to pull these SBC graphics after the fact. It's easy to pull surface analyses and radar data after the fact, but one really critical missing piece, I think, has been easily accessible satellite data, and I'm really optimistic that this is going to help, for not only event reviews, but also for case studies, research, that type of thing. And so that's really all I have for the presentation. I just want to summarize that there's a lot of potential here using Colab to access and explore all the data out there. And the ecosystem, as I put it here, is very powerful. There's all sorts of, going back to the Python language I was talking about earlier, it's very, very robust. I mean, there's so much work that's going on to make it very powerful. In fact, there's a whole Python system called MetPy, which, as the name implies, it's actually really excellent for visualizing meteorological data, including satellite. So I've already said that, yeah, there's a lot of potential here for case studies, event reviews, research, that type of thing. And I'll just end by saying that if you have any questions about any of this, please feel free to reach out to me any of the ways that I've got listed there. And that is all I have. Thanks.
Hey, TJ, thanks for that presentation. That's outstanding, outstanding capabilities there. I know, as assume myself, it's always difficult to be able to quickly pull up, environmental information that you want to share in a post-case review, where we can whip up some training really quick. So I think this offers us, like you said, that final missing link. So that we can have all the data sets that we need and do it very quickly. So that's fantastic. I guess before we get into the discussion period, I just want to remind everybody to first off, if you notice on the top center of the screen where there's your camera layout, where it says everyone, if you wouldn't mind switching over to active camera, that way you'll be able to see both myself and TJ for the discussion here, and that'll help everything. And we encourage participation of all field, all forecasters out in the field, and also those at headquarters to really participate in the discussion, and also to maybe bring a new idea for a future satellite book club presentation. We learn a lot from these presentations that we might not be aware of. So it's always good to bring the new research that you have to these kind of sessions. So if you've got any feedback that you want to share with the folks that run these satellite book club sessions, please fill out the short survey at the link provided in the chat here. And before we get into the discussion, I just want to announce what we have upcoming for next week. We've got on Thursday, May 23rd at noon Eastern time, that's 9 Pacific, David Boudreau, he's the head of lightering, and he'll be discussing tanker lightering and weather support. So that should be pretty interesting. And again, if you have any questions or need any satellite information for any research or case studies that you're putting together, feel free to reach out to the Tower S folks, either Kashad Bowman or Emily Maddox, to help you with compiling that data. But now that we have this new great tool, Kashad and Emily, you may not get as many requests here, so we'll be able to pull pull a lot of satellite data down through the Colab software here. So this is great news. So maybe give you guys a break. So anyway, let's get right into the discussion here and open up the floor for some questions. And just before I open it to everyone else, I just wanted to ask a quick question myself because, again, really excited about this new tool that we have, and want to hear a little bit more. Can you please tell us, TJ, what you believe are the benefits and maybe some of the challenges of using Google Colab using the Google Colab platform for obtaining archived satellite imagery over other platforms that you have used in the past?
Yeah, so the advantage is that normally to get data, you have to, it's like being at a computer where you have to have certain software installed, right? You have to have everything there, and if your computer doesn't have it, you're kind of out of luck, right? But with the Colab environment, you can install all the packages, all the software you need in that session, and so you don't have to worry about maintaining an environment or finding a place that has the environment. It's right there, ready to spin up. And so between that and having access to all the data that's available on AWS, on Amazon Web Services, it makes things a lot easier, a lot quicker, to turn around. Maybe I don't know if disadvantage is the right word. One of the maybe challenges is that using the interface, using the form is not maybe intuitive at first. I mean, it's not super crazy difficult, but there are a couple things that may trip people up at first. So I've thought about, well, maybe I should just do like a really quick YouTube video where it shows me doing the button clicks or whatever. But that's a pretty easy hurdle to get over, and that's kind of why I said earlier that if people want to reach out to me and see examples of it, they certainly can. And quite honestly, that YouTube video does a very good job too. So that would be a drawback, I guess.
Okay, yeah, great. Yeah, I think if you were able to put a video together and run folks through, kind of step by step, that would really help. Maybe folks that are, not coders or a little bit more apprehensive in that kind of environment to really easily access the data. So I think that's really helpful. If you have any questions in the audience, please go ahead and either post it in the chat or go ahead and raise your hand, and we can and unmute yourself. And please feel free to ask any questions. We really encourage that. So any questions out there?
I do see that. I'm sorry to interrupt. I do see that Kashad posted the there's a GitHub link in there. If you scroll up, I did see a little traffic saying that they couldn't access the Google site, which I could see how that would be limited. But that GitHub site, anybody should be able to access that. And if they got Gmail, they can open it up. So I definitely encourage you to give it a try.
Yeah, thanks for that. All right, so let's see. Okay, I do have a question that's come in from Huntsville here, NWS Huntsville. They say, hey, great tool you've developed, TJ. Do you recommend that others make a copy of this file for any editing for their own purposes?
Great question, and I didn't cover that. So when you run it, it's not like you're going to stomp over anybody else's work, right? So you don't have to make a copy of it. You can if you want, but it would almost be better if you didn't, because I'm always trying to make tweaks to it and update it and things like that. And if you copy, you won't get those updates. And so and you don't have to worry about if one person is using it and they're putting in their selections and another person is using it and making their selections. You're not going to be stepping over each other. It's not going to save the changes that you make, but you can make changes for your particular session select your times and channels and things like that, and create the products and download them. So yeah, it's pretty nice the way there's kind of that separation where everybody can use the same file without interfering with each other. So I would say just go ahead and use what I shared there.
Okay, yeah, great. We do have another comment that's come in and another question here. This is from a comment from Emmy Uphoff. The collab notebook is very cool. Okay, that's good news. So thank you, and she thanks you for running us through this. Then we got a question from Matt Woods. Does this work, or can it be made to work for mesoscale sectors, or is it just for the CONUS view?
Yes, so you can access mesoscale sectors. I haven't gotten that far yet in developing it, but yes, it is possible. It's available on AWS. It's just a matter of making the requesting that particular bucket of data. But yes, it can be done. The other thing I didn't say is GLM data. That's accessible as well. There's also other satellite data sets, JPSS stuff. I kind of want to explore that a little bit more. And like I said earlier, there's a really good ecosystem of people figuring this stuff out, and a lot of software that's just there for the taking. But I figured at least starting out, GOES, CONUS is what most of us use, and also a shout out to the people on the western part of the CONUS. I mean, I do have GOES 17 as well. Yeah, I see Alaska view. So I guess you could use GOES or Himawari. That would be a pretty nasty angle up in Alaska, though. So I mean, I guess it would kind of work. I mean, it's probably what you're used to, unfortunately, but that's maybe where JPSS and some other things would come in very handy as well. So yeah, by selecting instead of GOES 16 or GOES East, there's ways to visualize stuff in the West, which has actually been very cool. This is something else I would say too, is that it doesn't just have to be severe convection. There's those RGBs that are available, and if there's been some really interesting fires going on in the West, and you want to peek at how it looked, from GOES 17, for example, you could do that, because I guarantee you, I'm not archiving GOES 17. I'm not archiving any GOES West satellite data on my AWEBs here.
Right. Yeah, I don't think I do much of that either, being on the Gulf Coast. So we got another question here. Obviously, you answered Aaron's question about the view in Alaska. But Dan from NCRFC is asking, do you need to use the Google Colab app for your development? And is this available through our Google Enterprise Agreement?
So I'm not familiar with what you mean by Google Colab app. So basically, the way it works is you're just writing code right in that notebook itself. So when I was showing those screenshots of what the interface looked like, there's these sections that say show code, show hide code. So it's kind of like the ugly code behind the scenes that you can open up those windows and do coding in it. So all you need is that document really to do the development, to do the coding. But you also have the option of setting it up so people don't have to wade through all this ugly looking code, and they can just go to the interactive part that they would most likely be interested in, like selecting the time ranges and the lat long boxes and things like that. So I hope that answers your question, and if not, feel free to reach out.
Okay. Yeah. I don't see any other questions at the moment, but I got a few more here for you, TJ. Are you able to overlay other data, such as like archive model guidance, over top of the archive satellite imagery that you're accessing through Colab, kind of like what we do in AWEBs in the operational setting?
It is possible to do that. I haven't gotten that far, but on that NOAA open data link, you'll find that among other things, it includes like HER data, model data, HRRR, things like that. And so you can you can also access that and do overlays. Yeah, so it's theoretically very possible. And in fact, I know, talking about MetPy, that's a really good place to check out. I should have put a link on this. Although I do think in my Colab notebook I do have a link to MetPy. So I encourage people to just, you probably Google it and find it, METPY, and you don't have to be a coder to go in and just sort of appreciate some of the examples they show of how you can overlay different data sets. So yeah, definitely something I want to get more into.
Okay, yeah, great. That sounds cool. This seems like a pretty robust system where you can do a lot of stuff, and again, the ease of how you can use it, and also how quickly. I think that's really where, at least us Sues, we appreciate that when we can, pull stuff up quickly, easy, get right into the data, start training our folks. I think, having those discussions, especially like you said, when it's fresh on our minds, makes things more effective from the training perspective, I think. So yeah, this is great stuff. And I don't have any more questions that have come in, but maybe we do have a few minutes here. Maybe we can ask you, TJ, if you wouldn't mind running us through, actually how it works, and kind of giving us a bit of hands-on look at this. How would we do it ourselves if we're, after the fact here?
Okay. Well, this is the part where once you show it, it's going to have to break, right? So let's see if that's the case here or not. Okay, so looks like you can see the screen. Okay, so this is the actual document I have in the drive. So this would be just like sharing a Google Doc in NOAA, but there's also this right here. So this is, excuse me while I get a drink of water. This is in GitHub, right? So anybody can access this with this address. All you'd have to do is just click open in Colab, and then it would give you something that looks pretty much like that, so you're good. Okay, so first of all, you have to do all the installing. So notice how I'm just kind of like toggling things on and off to get it out of the way. So I've already done this, but it does take a little while, but it's a one-shot deal. You don't have to do it all the time. So here's an example of how you can select different satellite images, or excuse me, different satellite GOES satellites. Here's where you can select your start and end time. So you would just scroll which start and end hour. I've just got it to the nearest 15 minutes. Similarly for the end times.
TJ, just before we go any further, where you chose your satellite, do you have to add those in, like your data sources, or is that from up top when you first?
Yeah. So what happens is, and this is kind of a key step here, and it's actually a little tricky on this. This is one of those things I was talking about. Excuse me, my throat got really dry all of a sudden. Where you have to make your selections. Okay, so I'm going to just say, all right, I'm starting at 1745, ending at 2015. And by the way, I've had success making some really long animations, as you saw in the presentation. One of those was like over 3 hours long. So, I mean, this can only take so much. So the other thing I should say is that the resources that do all the computation and creation and stuff, they're allocated, they're shared resources, and so you're not given unlimited power to run stuff. But for the most part, it's pretty good. It allows you to do quite a bit. One of the things I would love to see our agency do is actually get more into like subscribing, to Colab. So we actually, for people who want to be more power users, they have like more of the access to do that kind of thing. But anyway, I'm getting ahead of myself a little bit. So once you select the start and the end times, you can select whether you want to do a certain time zone or not. So it'll know to change the hours accordingly. This is probably going to be here. You'll just be typing in the amounts. I have found that this can take the most amount of time where you're having to eyeball it and figure out exactly what dimensions you want. Okay. Um, I've actually got it. So if you're zoomed way out, if you're doing like a CONUS view, even if you did plot roads, I would nix it because you probably don't want, high density roads plotted on something that covers most of the country. It's going to get really, really noisy. Well, actually, I take that back. I think I did that for counties. But in any case, you do have those options there. Now, what was asked before by Dan is, okay, if you want to do development, all I have to do is just show you the code right here. Okay, that's what's going on under the hood. But most people probably don't really care about that, so I'm going to just turn that back off. And I've made all my selections. So now once you've made your selection, you're running it. You get a check box there. You can toggle stuff on and off. So now the next section is you can, if you want this for reference, you can do it. So all of these are drop-down menus. One thing is, as you know, the visible channel is the full resolution on it is essentially like half a kilometer, right, give or take. It's a much higher resolution data set than all of the other ones. And so I give the option of doing either the sort of coarser version or the more high res version. I would not advise doing a high res version if you're going to do like a CONUS wide plot. You probably don't need that level of detail, and it's going to bog things down. So that's why there's these two different options here. And then these are all the different RGBs that I have available, and so you can you can choose however many or how few you want. So like for example, I'll pick channel 9 here. I'm really becoming more and more of a fan of looking. I probably won't be a really great case for it here, but looking at channel 10, it's like, how good was that EML, right, that showed up? I'm really starting to pay a lot more attention to those kind of things. So this, excuse me, gives you the option to do that. And then the next step, this is the ugly code that you don't have to look at. So let me hide that real quick. But then at that point, you're basically clicking run on it. So I see we're kind of near the end here, so I probably won't run it. I know we're almost quarter till. But the upshot is once you run it, you're going to get something that looks kind of like that, where you're going to get the output. It's going to show here, but perhaps more important, you're going to be getting all these images, these mosaic images, depending on how many images you chose, right, for the mosaic, as well as an animated GIF, as well as a zip file, where you can. I would usually just download these two things, extract the zip file, and then pick and choose which satellite to use, and that's pretty much the workflow right there.
Okay, great. Yeah, thank you for all of this, and I know there's probably many of us out here that your email box may get populated pretty quickly here with additional follow-up. Get this running for us. So yeah, fantastic work, and thank you for bringing it to the book club here to share that with us. So really appreciate that. So I think we're getting towards the end of our time here. Again, thank you, TJ, for everything you've done here, and I'm going to go ahead and pass it back to Liz to go ahead and close us out. Thank you.
All right, thank you so much. Thank you, John, for leading the discussion, and TJ for your presentation today. Thanks again to everyone for attending today's session, and we look forward to seeing you back at the Satellite Book Club next week at 12 Eastern. Bye for now.